Okay, we're going to go over some problems where we're going to compare properties of functions. We're going to be incorporating some of the values that we talked about in our unit on linear equations. So when we were writing equations for lines, we looked at slope, we looked at the x and y intercepts, and we're going to be more interpreting those for real situations and then comparing those values. So we should be starting on page 309, and you're going to fill in on your packet as you listen to the video. So starting with this problem, we have two people that are visiting the Science Museum. We have Carlos. He got an annual membership where he is paying $29.99 and gets to go as much as he wants. And then Stephanie is represented by this table right here. You could see that if she goes once, it's going to cost her $5, twice $10, $3 $15, $4 $20, and $5 $25. And this is like total cost, running total. So we should be able to make a table to represent Carlos's membership. So he's just paying a flat rate annually. So we see right here that we have annually, that's every year. So we're just comparing 1 year for both of these people. And so if we're going to make a table to represent Carlos's payments, or how much it's costing him to go to the museum, after 1 month he would pay $29.99. 2 months, he still already paid that $29.99. We're not adding anything additional to the cost. After 3 months, he's still going to have paid $29.99. Actually a really good deal, I guess, for the whole entire year. And then the 4th month he would still have paid $29.99. So now we're going to look at the rate of change for each. We could see that for Carlos, let me change my color. So as the months go up, so these are increasing by 1 every time, this has an increase of 0. If we think of our month as our input, like X, and our output, Y, and thinking about slope, or when we were trying to find a constant, we would do change in Y over change in X, and that's going to be the rate of change. So the change in Y over the change in X, or rise over run, is going to be 0 over 1. Which should make sense, like he doesn't have a rate of change. So we could say for Carlos, his rate of change is, Carlos's rate is 0, and Stephanie's rate, we'll have to look at her table. So we could see that these are increasing up 1 each time. Over here has an increase of 5. Thinking about them the same way, X and Y, these are our outputs, so we want to put our change in our Y values on top, which would be 5, change in our X values on the bottom, which would be 1, and 5 over 1 for Stephanie would simplify to 5. So Carlos's rate is 0, and Stephanie's rate is 5. Let's put it as $5 per visit. And really, that literally rate of change goes back to slope. Okay, so who pays more for 2 visits? I mean, you could compare back up at the table. After 2 visits for Carlos, we're at $29.99. After 2 visits for Stephanie, she's only paid $10. So who pays more for 2 visits? We would say Carlos pays, oh, my pen just popped out. Carlos pays more. Stephanie, oh my gosh, having some technical difficulties. Stephanie only pays $10 for 2 visits. Okay, if we could even add in the price that Carlos pays. Obviously, a little hard for me to write on here, so I will just leave it at that. Who pays more for 6 visits? Okay, so still, our table for Carlos would be the same. We would have $29.99 all the way down. For Stephanie, we would really just need to add one more onto this table for 6 visits. So what I would add right here would be 1, this would go up to 6, and I would add 5 here, this would go up to 30. So that would be 6 visits for $30. At that point, that is the point where Stephanie pays more. She would pay a penny more. So Carlos would still have paid $29.99. Stephanie would go to 30. She'd actually pay 1 cent more than Carlos. So let's get that in there. Stephanie would pay 1 cent more than Carlos for 6 visits. Okay, so a lot of times we're going to get functions represented in different ways. Tables, equations, graphs, just verbal descriptions. We've seen a lot of those already playing our game and working on the assignments for functions so far. Most of these problems are going to involve 2 different representations, so we can't, it makes them a little bit harder to compare. So we have a zebra's main predator is a lion. Lions can run at a speed of 53 feet per second over short distances. The graph at the right shows the speed of a zebra. Compare their speeds. So we have what a lion runs, and that was given to us right here. So a lion can run at a speed of 53 feet per second. And then we have zebra over here, and we basically are going to need to interpret the rate of the zebra from the graph. The lion, it was given to us, 53 feet per second. We're going to have to interpret the rate of the zebra. So rate of change, again, we want to think of slope. Oops. Okay, so we want to think of slope, and that's literally where this equation is coming from. They're using 2 points and plugging it into the equation y2 minus y1 over x2 minus x1. Okay, the points that they're using are right here. So we have 159 and 118. Starting with y2, that would be this one. That's going in right there, minus y1, which is right here, 59, and then subtracting x1, which is x2, which is 2, minus 1. And that gives the rate of change for the lion, or for the zebra right here. So a lion travels at 53 feet per second. A zebra travels at 59 feet per second. And then obviously the zebra is faster. Okay, so let's do our extra problem. That should be similar to that. So we have a certain car has gas mileage of 22 miles per gallon. And then another sport utility vehicle is represented over here. So we're going to want to be able to figure out the slope of this graph right here. We could do it the way they did by using the ordered pairs that are given, and that's how we'll do it. So we'll take these two ordered pairs. I'm actually going to rewrite them over here to help me label and put it into the formula properly, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Oops. Let's get rid of that. Okay. So our points were 238 and 119. Thinking about labeling my points, I'm going to call this x2, y2. I'm going to call this one x1, y1. Then I'm just going to simply plug it into the formula. So I would have 38 minus 19 over, because that's my y2 minus y1, and then if I pick this number first, I have to use the number from the same point, so 2 minus 1 right here. Okay, then I'm going to finish up that work. Having difficulties with my pen. And we get 19 over 1. That would be 19 miles per gallon. So, you know, we could say that the sport utility vehicle has, you know, a worse gas mileage. So, you know, if we're only getting 19 miles to the gallon, that's not very good. Obviously, we're going to go for the car. So we could say the car has better gas mileage. All right, on to our next example. Okay, so we have a function, and we're given the equation right here, m equals 140 times h, where m is the miles traveled in h hours. Represents the distance traveled of the first Japanese high-speed train. The distance traveled of a high-speed train operating today in China is shown in the table. So we're basically going to need to interpret the table. Over here we have the equation given to us. Compare the functions y-intercepts and rates of change. So recall that we have our equation y equals mx plus b, where b is the y-intercept and m is the slope, and our slope is going to be our rate of change. So comparing the y-intercepts, we could think of, you know, on our graph, the y-intercept somewhere around, you know, here, anywhere on this y-axis, and on the y-axis, x is equal to 0. So we're looking for when does our input, our x, equal 0 in the table. That would be 0 hours. So after 0 hours, no distance has been covered. The y-intercepts are the same. The train hasn't started moving. Then it says compare the rates of change. The speed of the Japanese train is 140 miles per hour. I mean, if we just go off of our slope-intercept form, we see that our rate of change is always going to be in front of the variable. So even if I have a different variable than x and I have h instead, it's going to work the same way. So 140 miles per hour. To figure out the speed of the Chinese train, we're going to need to, you know, look at how the numbers are changing. These are going up by 217 for every 1 hour, so that would be 217 miles per hour. Since 217 is greater than 140, the train in China is going faster. Okay, I'm going to be ending part 1 of this video. To carry on with the question, you're going to need to start watching part 2.